Welcome to Oryx Learning. Today's lesson is going to be on Unit 1, Real Numbers, Lesson 1, Rational Numbers. So you may find yourself in a situation like this, where it says, for my birthday party, I ordered a pizza to share with my friends. I announced that they could each have 0.375 of one pizza. Each pizza has 8 slices. I offered a prize to any friend who could calculate how many pieces each person could eat. Knowing how to change the given decimal to a fraction would be very useful in this situation, and that's what we're going to focus on for this lesson today. Remember that when dealing with the real number system, system can be broken down into different groups of numbers. These groups being rational, irrational, integer, whole, and natural. Right? Our rational numbers are the numbers that we're going to focus on this lesson. They are those numbers that can be written as a comparison of two integers or just expressed as a fraction. So you'll see in the rational circle, we have things like 2/3 and negative 0.2 or negative 2.65. In the integer circle, within the rational circle, we have the number line numbers like 0, -3, 5, and -19. The whole numbers are just our positive integers, right? So we have 0, 5, 3, numbers like that. And then for the natural numbers, we have the same group as the whole numbers, just not counting 0. So it would start with 1, and then the whole numbers after that, 1, 2, 3, etc. On the little island over there on the right is our irrational numbers. Irrational numbers are numbers that cannot be written as a comparison of two numbers or as a fraction. Numbers like pi, square root 2, square root 5, e, things of that nature. So again, we're going to focus in on what is a rational number. A rational number is a number that can be written as a comparison of two integers, as a ratio, and expressed as a fraction. Rationals come in all shapes and sizes. They can be both positive and negative. They can be whole numbers like -2. They can be 0. They can be negative 0.125, 2/3, square root of 4, anything that can be written as a comparison of two integers or as a fraction. So for our first example, it says select all of the rational numbers below. So feel free to select more than one. Select all the rational numbers below. In this case, the rational numbers would be 7.2%, right? Percents we can divide by 100, write them as a fraction. 0.05, right? That's 5 1/100ths. 4 sevenths, obviously a fraction. The only one that is not rational is this square root of 10. The square root of 10 is not a perfect square and cannot be written as a relationship or comparison of two integers. The second example, find the quotient of 611 divided by 13 using long division. So whenever we use long division, the divisor, the denominator, the bottom number, is going to go on the outside, and the numerator, the dividend, is going to go on the inside. So we will set it up like so, right? So we ask ourselves, does 13 go into 6? The answer is no. So I put a 0 there and bring the 0 down. So now I ask myself, does 13 go into 61? 13 goes into 61 4 times. 13 times 4 is 52. So I subtract the 2. 61 minus 52 leaves me with 9. Bring the last one down. How many times does 13 go into 91? And 13 times 7 happens to be 91, so there is no remainder. So 611 divided by 13 gives us an answer of 47 using long division. For example 3, write the mixed number 1 3/5 as a decimal. We just have to worry about the fraction component here. So if I take that 3/5, I could use long division and divide it out. Or I can change the entire thing into a improper fraction and then change from there. So in this case, I will change to an improper fraction by multiplying the whole number times the denominator, adding on the numerator. So 1 times 5 plus 3. That gives me 5 plus 3, which is just 8 over 5. And then similar to the last problem, I can divide 8 by 5. Right? I ask myself, how many times does 5 go into 8? That is 1 time. Subtract them. 8 minus 5 is 3. I put a decimal point, bring down a 0, just as a placeholder, and I ask myself, how many times does 5 go into 30? 5 goes into 30 6 times, making this decimal 1.6. For the next example, write the decimal 0.625 as a fraction. In order to write a decimal as a fraction, right, we want to figure out the place value of the last number to the right. So if I look at that last number to the right, the 5 is in the thousandths position. So that's 625 thousandths. So 625 divided by 1,000. Right, I want to reduce that down. If I reduce it, I can reduce it by lots of different numbers, but if I pick the largest number that goes into them, the greatest common factor, it will be the least amount of steps. So in this one, the largest number that goes into both 625 and 1,000 would be 125. If I divide 625 by 125 and 1,000 by 125, this fraction reduces all the way down to 5/8. All right, our next example, write the decimal -3.24 repeating as a mixed number. So we're going to start out by just looking at the repeated value, and we're going to assign a variable, in this case a capital N, and that capital N is going to represent whatever a part of the decimal that's repeated. So in this case, that 0.24 repeated, 0.24, 24, 24, etc. We're going to multiply by 100 on both sides in order to change that decimal. So 100 times n and 100 times 0.2424, etc. We're going to subtract off one n value, which is that 0.2424, which essentially is going to get rid of the repeating decimal, just leave us with a whole number. So 100 minus 1 is 99n, 24.24 repeating minus the 0.24 repeating is just 24. And then in order to isolate the n, to solve for n, I'm going to divide both sides by 99, giving me n equals 24/99. Now that's only the decimal piece, so I need to combine that with the whole number, that -3, and make it -3 and 29, or 24/99. Our last example, the distance from Maya's house to school is 2.125 kilometers. Write the distance as a mixed number. So again, we just have to look at the decimal portion of this. So we're going to look at the 0.125, and we're going to see that again, the 5 is in the thousandths position. So that means I'm going to write 125 thousandths, or 125 over 1,000. I need to reduce it down by the greatest common factor, which in this case again is 125. So 125 divided by 125 and 1,000 divided by 125 would reduce all the way down to 1/8. That, of course, is just the decimal portion, so I'm going to combine that with the whole number 2, and I'm going to get 2 1/8 kilometers. She's going 2 1/8 kilometers. Now back to our pizza example. In situations like the pizza example, understanding rational numbers could be very useful, as we saw. So knowing how to change 0.375 to a fraction in simplest form makes it pretty easy to calculate, because we just have to figure out that 3/8, or 3 of the 8 pieces of pizza, would be the amount that we get to eat. So in conclusion, a rational number is just a number that can be written as a comparison of two integers expressed as a fraction. And every rational number can be expressed as a decimal by dividing the numerator by the denominator. So here comes some rational numbers in, right? Remember, negative numbers, positive numbers, fractions, decimals, square roots of perfect squares, repeating decimals, all of these things are rational numbers. So that's it for the lesson. That was Unit 1, Real Numbers, Lesson 1, Rational Numbers. Thank you for joining me.